The circle C has centre A 2, 1 and passes through the point B 10, 7. Part A finds an equation for C. Well, all circles have the equation x minus a all squared plus y minus b all squared equals the r squared, where a, b is the centre of the circle and r is the radius. So in this case, my a is 2 and my b is 1. So let's put those in the right place, right at the beginning. We now just need to work out the radius. Well, if the centre is 2, 1 and the circle passes through the point 10, 7, then I can work out its radius by just doing a little bit of Pythagoras, just working out the distance between those 2 points. So we can do that by looking at the x-coordinates. The change in the x-coordinates there is 8. The 10 take away the 2. So we have 8 squared plus, now we'll look at the change in the y-coordinates, which is 6 between 1 and 7. So we have 8 squared plus 6 squared, all square rooted, will give me the radius, the distance between those 2 points, which is 10. So the radius of this circle is 10, which means that the radius squared will be 100. And that's the equation of my circle. Part B says the line L1 is tangent to the circle at the point B. Finds an equation for line L1. Well, if it's a tangent to the circle, then I know that that means it's perpendicular to the radius at that point. So if I can work out the gradient of the radius at B, then I know the tangent will have the negative reciprocal gradient. So the gradient of the radius, I'll call it MR. So the change in the y-coordinates, 7 minus 1, divided by the change in the x-coordinates, 10 minus 2. Which gives 6 over 8, or 3/4. So the gradient of the radius at point B is 3/4. Which means then that the gradient of my tangent will be the negative reciprocal of that. So will be minus 4/3. So my tangent will be y equals minus 4/3 x plus c. We just need to work out c, which we can do because we know that our tangent passes through point B. So I know that my y-coordinate is 7 when my x-coordinate is 10. Just substituting point B, the coordinates of point B in here. Add the 40 over 3 to both sides to work out what point C is. I'm going to get a common denominator here, so let's call that 721 over 3. And I find that C is 61 over 3. And that's the equation of my tangent at point B. We're then told that the line L2 is parallel to L1 and passes through the midpoint of AB. So parallel, so it has the same gradient and passes through the middle of A and B. Given that L2 intersects C at points P and Q, find the length PQ. Now, several different ways you could do this question. probably the easiest one is to do some simultaneous equations to work out the coordinates of P and Q, and then we can work out the distance between them. So P and Q is where L2 intersects the circle. So let's work out the equation of L2. I know it's parallel, so it has the same gradient. So y equals minus 4 over 3x plus something. And I know it passes through the midpoint of AB. So the midpoint of AB, I can work that out. It's going to be in the middle of these two coordinates A and B. So the middle of 2 and 10 is 6. If you're not sure where I got that from, you can always just do 10 plus 2 divided by 2. The middle of 1 and 7 is 4. Again, if you're not sure where I got that from, you can do 1 plus 7 divided by 2. So I know that the y coordinate is 4 when the x coordinate is 6. So I find that C is going to be equal to 12. Now I've worked out the equation of L2, I can do simultaneous equations with my L2 and the circle to work out the coordinates of P and Q. So let's do that. Let's create a little bit more space by just getting rid of that. So let me substitute the straight line into my circle. So substituting this in instead of the y. I can do the 12 minus the 1 is 11. I'm going to expand all those brackets, so I'll get x squared minus 4x plus 4 plus 16x squared over 9 minus, that's going to be 88 over 3x plus 121 equals 100. I'm now going to collect up like terms. So we've got, actually, I'm going to multiply everything through by 9 first, I think, to make this a bit simpler for me. So timesing each term here by 9, we will get 9x squared minus 36x plus 36. The 9's there will cancel. The 88 over 3 times 9 will be 264. The 121 times 9 is 1089, and the 100 times 9. Now let's collect up the like terms. Now we've got rid of those fractions. So 25x squared minus 300x, and collecting up the constants, we get plus 225 equals 0. Each term there will divide by 25 nicely to get x squared minus 12x plus 9 equals 0. We can now solve that quadratic. I don't think that's going to factorize very nicely, but we can use either complete the square, or we can use the quadratic formula. Or this question didn't say you couldn't, so you could use your calculator to do this. And we will find that x is either equal to 6 plus 3 root 3 or 6 minus 3 root 3. We can now work out our y coordinates by substituting those back in. to our y equation. So let me just create a little bit of space here, move this up here. So if I substitute each of those into here, so y equals minus 4 over 3 times the, let's do the positive one first, let's do this one here. So the 6 plus 3 root 3, and then we'll add the 12. We get y is 4 minus 4 root 3. And if we do exactly the same thing now with the negative, we get 4 plus 4 root 3. So we have worked out that point P is the coordinate 6 plus 3 root 3, 4 minus 4 root 3. And the point Q is 6 minus 3 root 3, 4 plus 4 root 3. We can now work out the length between them by doing some Pythagoras, by working out the change in the x coordinates. So this take away this, all squared. So when we take those away, so the 6 plus root 3 minus the 6 minus 3 root 3 will give 6 root 3. Which will square, because we're doing Pythagoras here. Then taking the y coordinates away, we will get 8 root 3. Which again will square. And when we square root that, we will get the answer 10 root 3, which is the distance between those 2 points P and Q. So that's the long but straightforward way of working out point C. There is another way you can do this with circle theorems and by drawing a sketch. If you want me to go through that, then just let me know in the lesson. But hopefully that is enough for that to help you understand how to actually answer the question in the more traditional algebraic way. For your homework, let me know if you need any help, if you want me to show the other way when we review this in lesson.